Okay, so we're live. I think it's going on. Yeah. So let's start with this presentation. Hello, everyone. Welcome to this presentation of the Weather on the Edge project. Well, my name is Adrian, and I'll be presenting along with Lydia and Andrea. So, well, let's move into the contents. What are we going to explain? So, we're going through, I don't know if you see you see the slides, okay. We're going to, first of all, we're going to introduce the project. So we're going to talk about, the context and the goal of the project and the benefits. And then we will move through the different, we will delve into the parts of this project. So there are three main topics. First, we will talk about the edge device, so everything related with the edge device, the architecture, and what's going on inside. And then we will move about the cloud. So we will talk about the resources, the architecture, also infrastructure as code. And on the third part, we will move into the machine learning part. So we'll talk about the modeling, the evaluation, also optimization, machine learning pipelines. So those are the main topics. And then at the end, we will talk a little bit about the next steps of this project. And of course, we'll have a space for questions. So during this presentation, if you have any questions, just don't hesitate to write it down. And at the end, we will try to answer all. So let's get started with a little introduction. So let's go with the scope of the project. What is the context of this project? So we started, this project is done by the members of the Roots Academy. So the Roots Academy, it's a training program that we have here in Data Roots that is meant to train and to learn the best practices of a data consultant. So we did this project. It's a 1 month project. We did it in order to apply all the concepts that we learned during the Roots Academy, and try to simulate a real scenario where we have interactions between teams, between the client, etc. So for that, we are 3 teams. We have the edge team with 2 people, the cloud team with 2 people, and also the machine learning team with 3. And all of those teams, each of those teams is supervised by an expert on the area. So that's a little bit of the context where this project it's done. The objective of the project is to forecast weather. To make predictions of the next 4 hours of some weather data. So and we do that on the Data Roots office. So in order to do that, we have an edge device. So we gather the data and we made the predictions on the edge with that data. So that's the whole point, the whole goal of the main goal of the project. And well, that can have a lot of benefits. Just to mention, once we have the first data, we can have real data of the weather at the Data Roots office, and also we can have more ambitious goals, like for example, try to anticipate disasters related with the weather. So that's a little bit of the goals and the benefits. And just to go a little bit more in depth of the scope of this project, we thought that we're going to predict some weather data, but we're going to have 6 sensor data points to predict. So we gather our own data and we can split it into different types. So first we have the sensor data, so temperature, humidity, pressure, light, etc. And we also have images of the sky. So that's our data sources. And also it's important to mention that we work with the Azure environment. So Azure is the Microsoft cloud service provider, and we will use it for most of our applications, from having the platform for communication between the edge device and the cloud to create the machine learning pipeline. So we work with the Azure, Microsoft Azure. And as I mentioned, we are 3 teams, but we are not isolated teams. In fact, we have a lot of connection between the teams. As you can see in this slide, if we start with the edge team, the edge team gathers the data, send it to the cloud, and then in the cloud, well, we need, of course, communication between the Edge team and the cloud in order to set up all the resources and the architecture, and also the machine learning team that deploys the machine learning pipeline in the cloud has a lot of communication, and it depends on the cloud team. And in order to close the circle, there's also communication between the Edge team and the machine learning team, as we perform the inference on the Edge. So we need the Edge device and the model in the same place. So there's a whole communication in this project. So yeah, that's a little bit of an introduction of the project. I see that there's some people joining. Maybe they didn't, because I say it at the beginning, but just to mention again, at the end we will have some section for questions. So if you have some questions about each of these topics, just write it down on YouTube, and we'll try to answer them. So well, now we move into one of the main topics of the project, which is the Edge device. So I'll be presenting this part. So first of all, what we did in the Edge team. So we have two goals. The first one is to set up the device. So basically set up all the configuration between the device, the sensors, the camera, also the physical installation. And the main part here is, the architecture itself, where we are going to have our application to set up. And for that, the main tools that we use is related, of course, with Azure. So there are two concepts: models, routine, also the Azure SDKs that I will talk about in depth in a moment. And also, the other goal is to actually make it work. So send the data, gather the data from the sensors, and send the predictions. So perform the inference on the Edge. And for that, what we do is gather sensor data every second, and we gather the images every 10 minutes. What is the setup that we used? The Edge device is the Jetson Nano, the Nvidia Jetson Nano. So it's a Edge device with a GPU that is optimized. So it's perfect for inference on the Edge. And we will also have an encased temperature and humidity sensor, which is, here is because we have a problem with because the Jetson Nano already has attached some sensors, but we experienced some problems, for example, with the temperature, because when the device heats up, then the temperature sensor gathers that data and it's run data, of course. So we have to use an external sensor, and also for the camera, we use a Raspberry Pi camera. That's a little bit of the setup in the Jetson Nano. And then on the other hand, we have a Raspberry Pi. So we use a Raspberry Pi basically as a self-hosted run for GitHub Actions. So here, this is something more provisional than, because in production you can always use a runner by GitHub. But in our case, basically we have already a Raspberry Pi, and we have problems in order to find a self-hosted runner, a runner from GitHub that runs on an ARM architecture. So the Raspberry Pi was perfect for that, and we have the full control of it. So we use it to build basically and push the images to ACR, to the Azure Container Registry. So what is the process of, what is the architecture of that is inside the Edge device? So this is the main part, I would say, of the whole Edge team. So I'll try to explain it as good as I can. So first of all, we have the IoT Hub. So the IoT Hub basically is the tool that Azure gave us in order to allow the communication between the Edge team, between the Edge device and the cloud. So basically it allows the communication, so we can send the data, and then we use some concepts in some tools in the IoT Hub. One is the modules that I already talked, and the other is the deployment manifest. So I would talk first about the modules. Here you can see we have 4 modules. These are the first word, the sensor, communication, prediction. A module, basically, you can think of a module as a container. It works as a container, but it has more features than that in order to fit in the Azure environment. So, for example, you can easily pull the image from ACR. you can allow some communication, some routing between the different models. So yeah, that's really nice, and that's the way to go in order to build those applications. So in our application, we have 4 modules. We really have 2, the sensor and the prediction, that are the ones that we created, and then we have the modules in the Edge runtime. So the Edge runtime basically is the set of tools that we need in our Edge device in order to communicate with the IoT hub. So for example, the Edge hub module basically enables the communication, so it acts like a proxy for IoT hub. And then its agent, it works for the deployment, and also it's really important for monitoring. So when developing, it's indispensable. But the models that we recreated are the telemetry model and the inference model. So the telemetry model basically is a model where we gather the data from the sensors, and then we send that data. So we send that data to the cloud in order to preprocess and build a machine learning pipeline. And at the same time, that first data, we send it to the inference model where the inference is going to happen. So in the inference model, we have that data, we have the images, we have the sensors, and we're going to make the predictions. So we also have the machine learning models. And when we make the predictions, we send those predictions to the IoT hub. So yeah, and all of that it has the relationship with the Edge hub. So everything has to go to the Edge hub. So yeah, that's the way it goes. There's a lot of there's a lot of things that a lot of details. You can ask if you have some questions, you can ask about it, and we try to answer later. Also, just to mention, we're actually writing a blog post about it, so we will go more in depth into this architecture. And and the other important part of the architecture is the deployment manifest. So the deployment manifest basically is a JSON file where we specify all the configuration that we need to run the modules, to run our application. So yeah, basically everything is there. We have the module, so we have to select the images that we're going to pull from Azure Container Registry. We can also set up the routing, so where the messages are going to go from models to cloud, from models to model, etc. So basically all the deployment is there, which is great in one hand, but also it has some downsides. For example, you think about if you're working with a lot of teams and you're working with a client and all of them want to interact with the deployment with that JSON file, every time you push a new JSON file is going to override the other, so you're going to experience some problems. And for that, the solution that we had is to create an API. So basically, we have the JSON file in a storage account in Azure. We access that through the API, we edit, and every time we edit, we trigger the deployment. So that's one of the solutions. Of course, it can have other downside because we don't have. If we do that, we don't have the CI/CD pipeline in the same environment in GitHub Actions. But it's great to have the flexibility to decide. So, for example, for developing, you can have the full CI/CD pipeline, and then for production, if the client wants to access, for example, the JSON via an API, that's a great solution. So, talking about the CI/CD pipeline, this is the CI/CD pipeline that is working on the Edge. So, first of all, what we do is every time we push the code to GitHub, it works with GitHub Actions, as I say, with Raspberry Pi. And every time we push some code, first of all, we create all the variables, all the credentials that we need in order to run the application. And then the main tasks are first to build the images for the models, and then to push those images. And once we push those images and we have the correct version and image in Azure Container Registry, we can just, with one command, deploy every model and every communication that the model has. And we do that with the IoT Edge Dev tool, because we have some problems with the Azure SDK as it's really limited for those kind of tasks. But yeah, that's the way our CI/CD pipeline works. And yeah, that's it for the Edge device. So yeah, now Lydia will talk about the cloud. Also, because I see that there's people joining, I repeat it. If you have any questions, you can You can just write it down and we will answer at the end. So now, yeah, I give the floor to Lydia.
Hello, I am Lydia. I'm part of the cloud team, and I will present a bit about our project. I will start with our goals and the idea that we had. Adrian, can you please? Thank you. First of all, we were responsible for configuring the cloud platform. So we started because we were beginners and we didn't have a lot of knowledge about how everything works and how everything should be connected. We started by creating manually all the resources that were needed in order to actually start the gathering of the data. So basically here we created manually all the Azure resources. We set up the Snowflake account, and we also made the connection between the storage accounts and Snowflake, so the data flow can help the other teams actually communicate with each other. After we got accustomed to the resources that we needed, we wanted to use infrastructure as code in order to have in order to be able to replicate the environment. So we turned our attention to Terraform. And on top of that, we wanted to have a good workflow of CI/CD. So we used GitHub's Actions. I will get in more details in a few minutes. But now, I think that we talked a bit about the resources. We will move to the architecture. So as you can see, the main elements are the Azure, the Snowflake, and GitHub. On Azure, we have the IoT Hub. Adrian mentioned it before. It was an important resource in our project. So as you can see in the image, we have the logo of Nvidia, which represents our IoT device, and it is connected to Azure through the IoT Hub. Whenever the IoT device sends messages to the cloud, we stored all the messages in storage accounts. But here I'm not talking only about messages. I would like to clarify that we have three types of storage accounts. So basically, we have a storage account for storing all the weather information. So all the data that's coming from the sensors. We have a storage account for storing all the images taken from the sky, and also we have another one for storing all the predictions. We also have Snowflake, where we store all the raw data, and there we can clean it up so that the machine learning team can use it in their pipeline. You will notice that we have some elements like the stream analytics or time series insights, which I did not mention until now. These were not used, but they are some nice to haves in order to actually gain more insights into the data. So when we started working on this project, we had in mind only two environments, the development and the production environment. But as we started to work on it, and we decided to start by creating everything manually, we discovered that the development environment is actually that one, everything that we created by hand. So this is happening in our sandbox subscription in one resource group. After everything was set up, we could make more environments. So we decided to create the staging and the production environment, which were created using Terraform, so the replication was quite easy to make. So here in the Roots Academy, we have 3 resource groups: the staging, production, and edge environment. What is most important here, perhaps, is the edge, because as you can see in the right, we have some, we are stating that in each resource group, we have some resources, but this is not the case for the edge environment. The edge environment is actually containing only a storage account, which also contains the backends to our Terraform. So this environment is quite special. But for the staging and production, and also for the development, we have multiple storage accounts. As I stated before, we have 3 use cases for the data. We have application insights, which helps us to understand and monitor the accuracy of the model. We have the container registry that Adrian mentioned before, which helps to register all the Docker containers. We have the IoT Hub, which is a key point. Then we have the Key Vault, which is responsible for storing all our secret information. We have the machine learning workspace, and we have an event grid system topic, which actually helped us to make even stronger the data flow between the edge device and Snowflake. Well, now moving on, we will talk a bit about the combination of Azure and Snowflake, so that you can have a better understanding of our how the data flow is actually created. So we have the IoT device, which sends information to the cloud every second. But in order to not have a file, so in order not to create a file every second, we decided to store all the messages received in a queue, so that every 5 minutes we write a single JSON file in a storage account. This is only for the weather information. So here I'm not talking about the images. When that file is created in the storage account, Snowflake is notified, and it can actually load the data in a specific table that we are targeting. This will be more clear maybe in a few seconds. Now we will move to terraforming Snowflake. Here, so we will create a blog post about it, and you will have more information. As I was saying before, we will try to explain everything as best as we can, and because, well, this part of the project was a bit challenging, as there is not a lot of documentation online, and the one that is not complete. So we were quite happy with the fact that we taken this challenge, and that we actually completed it. So stay tuned, because we will have a blog post about it in case you are curious about finding out more. And the last aspect that I would like to talk about is how the CI/CD pipeline works. So before you actually can push any code to your branch, there is a pre-commit hook. That's actually something that checks if the code you wrote actually respects some rules. After the code is pushed on your branch, you can create a pull request to merge the changes in the master branch. And here the tests will run and the formatting will be checked. But most importantly, here is the Terraform part. It's actually going to initialize, it's going to check the format, it's going to validate, and most importantly, it's going to plan. So now you will be able to see everything that is going to happen in the staging environment. If the pull request is approved and you decide to merge, here the changes will be applied. So the previous changes that we saw in the plan step will be applied now. And you will see the plan for the changes to be applied in the production environment. If you decide that that plan is also what you want, you can move over and you can actually apply the changes to the production environment by pushing a tag, so by creating a release. So that was the what we did in the cloud team. I'm looking forward to your questions, but for now I will give the floor to my colleague from the machine learning team, Andrea.
Thank you, Lydia. So, hi everyone. My name is Andrea, and I'm representing the machine learning team. So, first of all, to summarize what has been discussed so far regarding the project, the first thing was to describe the scope of the project. So, we want to forecast the weather features in the next 4 hours by using an edge device. Then Adrian discussed about how we were able to collect all the necessary data onto the edge device. And with Lydia, we discovered how we were able to set up an infrastructure on Azure to get the data from the edge device and to perform some pre-processing. And now it is time for the machine learning part. So how we developed a machine learning model to forecast the weather in the next 4 hours. So as machine learning team, we worked on two main milestones. The first one being optimization. So the idea is that we want to deploy a machine learning model directly onto the edge device, and this machine learning model will send the predictions every second. So we need the model to be as small as possible and as fast as possible to send these predictions. Therefore, the first part of the work of the machine learning team was to try to optimize the model as much as possible, and I will give you more details in the next slides. And the second goal that we had was to create some automatic machine learning pipelines on Azure to use them to pre-process the data, to prepare the data for our model, and then to train and assess the performance of our model. And again, all the steps of this pipeline will be discussed in the next slides. But first of all, I think it's important to give you a general overview of the machine learning model. So we start from the data collected by the edge device. We can split this data into two different categories. We have the 6 weather features, for example, the temperature, the humidity, and the pressure recorded at that timestamp. And then the edge device can also capture an image of the sky. If you want to use this data, regarding the sensor data, it is easy because it's already represented by numbers, but we need to add an intermediate step to preprocess the image. So what we had in mind was to use a quite complex and already pre-trained model. It's a convolutional neural network trained on thousands of images. And we want to exploit this quite complex model to transform the image into something that can be then used by another machine learning model. So basically, we transform the image into a vector. This process is called embedding. And this vector is a numerical vector and has all the essential features related to the image. Then after that, we can combine the vector with the other features, so the temperature, the humidity, and so on. And we can use all of this input data to feed it to another custom machine learning model, for example, a random forest or another simple neural network. And this model will be responsible of giving the predictions of the weather in the next 4 hours. But as I said before, we're using quite a complex model, as you see here, quite large, and we want to deploy it directly onto the edge device. So we need to optimize it to make it as small as possible. So as you can see in the next slide, we use two different techniques, two optimization techniques. The first one called quantization. And basically, quantization is a process that reduces the precision of the weights and biases used by the neural network. So in general, the math operations are performed in a format, in a float 32 format. But with quantization, we can simplify this format to optimize the memory and go from float 32 to integer 8. And the other technique that we try to study and to use with our model is called distillation. And the main idea is that we start from a pretty large and complex model. We can select a smaller model, and then we can transfer the knowledge from the large model to the smaller model. And then we will be using directly the smaller model to make our predictions. So we will gain some memory reduction, and also the inference time will be usually faster because we're using a smaller model. And I think it's very interesting to give you some results about the studies that we conducted on optimization. So we started from a quite big model, DenseNet 201. It's a neural network trained on thousands of images, and the size of this model is 71 megabytes. And we decided to assess the performance of the model on another data set of images called Caltech. And DenseNet 201 was able to reach an 89% accuracy. And then we conducted a study on both optimization techniques. So for example, we tried to quantize the model. We reduced by 6 megabytes the size of the model, as you can see in the last row of the table. But we encountered an issue with quantization because it was the inference, the predictions was performed on CPU. So it took a very long time, and therefore we weren't able to get a final answer on the accuracy of the model. But we were a bit more lucky with distillation. So we decided with distillation to select a smaller model. Again, it's another neural network called SqueezeNet. But as you can see, it's way smaller compared to the DenseNet 201, only 3.3 megabytes. Originally, this model was able to reach an accuracy of 72%, but by using distillation, we were able to improve this accuracy to 74%. And it's important to underline that we only trained for a few epochs. If we had trained for more epochs, for sure, we would have improved even more the performance of the distilled model. So for sure, these are promising results regarding optimization. And then the second part of the project for the machine learning team was to create these automatic pipelines. We created two different pipelines on Azure Machine Learning Workspace. And the first one is called the data pipeline, and it is responsible of getting the data from the cloud, preprocessing the data, and prepare it to be used by a machine learning model to get the predictions. Basically, the first step consists in fetching the data from the cloud. We get both the sensor data and the image. We can also create some extra features, perform some feature engineering. And then, as I mentioned before with the model overview, we will also transform the image into a numerical vector that can be used by the machine learning model. Then the second step of the pipeline consists in creating the target. It will be a supervised learning model. So we will create the 6 weather features that we need to predict in 4 hours. And also, we're going to split the data into two different sets. So a training set, and as the name suggests, the training set will be used to train our model, and the validation set that will be used to assess the performance of the model. And then we also have a third step in this pipeline. So basically, as I said before, there will be a model directly deployed on the edge device. This model will send the predictions every second, and these predictions will be sent to the cloud. And so in this pipeline, we're also collecting the predictions. And if we're monitoring these predictions, and if they're getting worse and worse, then we can trigger the second pipeline that I will describe you in the next slide, so that we can train a new machine learning model and improve the performance of our model on the edge device. So regarding the retraining pipeline, as the name suggests, we're going to train a new model on the last data when the predictions are getting worse and worse. And this new model will be stored in Azure Model Registry to keep track of everything. So this is the first step. And then the second step will be evaluating the performance of the model. So we're going to use the validation data that was prepared by the previous pipeline. And then we're going to assess the performance of the new model on the validation data. And if the performance of the new model are better compared to the performances of the model deployed on the edge device, this new model will be sent to the edge device and will be then responsible of sending the predictions every second. So this was like the overview of the two main goals that we worked on as machine learning team. And as also the two other teams, we developed a CI/CD pipeline to make everything more automatic. So basically, every time we push new code and we modify these pipelines, there are some GitHub actions that we designed to make everything automatic. So we set up the Azure command line interface. We can log into Azure directly using our credentials. Then we need to connect to our Azure Machine Learning workspace on which we defined our pipelines. And finally, we can submit the pipeline again with the new code that is being pushed. So this is like a general overview of the CI/CD pipeline that we developed. And finally, this project was a great opportunity also to adopt some MLOps best practices. MLOps basically is a set of practices that aims at deploying and maintaining machine learning models in production in a reliable and efficient way. And what we did was, for example, save every machine learning model that we developed into Azure Model Registry, and also track all the experiments with our pipelines. And we automated our pipelines with some trigger. And also, we every time a new code is pushed with this, the pipeline will be deployed automatically. And finally, also the deployment of the model from the cloud to the edge device has been designed automatically. So these are the best practices that we adopted for this project. And finally, to summarize, this project was a great way to learn about different topics. Of course, there are still many possibilities that can be explored related to the domains of Industry 4.0 and Internet of Things. So a couple of ideas for next steps. For example, it would be very interesting, instead of using a single edge device, to make use of multiple edge devices set up in different locations, in different areas, so that every single edge device can send its data, and the model can be even more precise at predicting the weather. And this, for example, could be a good basis for techniques such as federated learning. Federated learning is a machine learning technique in which we can train an algorithm using multiple decentralized edge devices. And this could make our model even more precise. So this looks promising. And as I said before, it was like a very interesting project. It allows us to learn a lot, to discover very interesting topics. And now, if you have any questions for me, for Lydia, or for Adrian regarding what was discussed in the presentation, we're more than happy to answer your questions. I don't see any questions. If you're curious about something about the presentation, feel free to ask.
I think, well, Paolo is asking what was the cost of the cloud setup. So, yeah,
yes, because we did not manage directly the subscriptions, we didn't have access to see the cost.
if you want to ask other questions and right now you don't know, like you can still ask them in the chat and we'll answer them. And how important is the input image in the prediction? Asks Paulo. Okay, so well, regarding the project, we were able to deploy the machine learning model on the edge device, but we had some issues with the quality of the data. So I cannot give you a final answer regarding that. But we think it's also important to take into account the picture of the sky and not just the data sensor that is collected by the edge device. But we don't have a numerical result to give you for now. Are there any other questions? I cannot see other. Okay, so thank you for your attention. And we remind you that next month there will be a public presentation for Snowflake. So hopefully we'll see you there next time. And thank you again for attending the presentation.